Hello students, from the chapter alcohol, phenols and ether, we have already studied the preparation of alcohol from alkyl halide, from alkene, hydroboration oxidation from carbonyl compound. So let us further study again preparation of alcohol by Grignard reagent. The general formula of Grignard reagent is RMgX. R means alkyl group, Mg magnesium and X halogen. You can use any alkyl group or any one of the halogen in Grignard reagent. All the three types of alcohol can be prepared by this method. Means you can prepare primary alcohol, secondary and tertiary alcohol. In this method, aldehyde or ketone undergo nucleophilic addition of Grignard reagent in presence of dry ether to form a complex which on acid hydrolysis give alcohol. Just see the general reaction. As all of you know, C double bond O means if you are taking RC double bond OH, so it's aldehyde, and RC double bond OR, so it's ketone. You can take aldehyde or ketone. So aldehyde or ketone react with Grignard reagent means RMgX, or aldehyde or ketone undergo nucleophilic addition of Grignard reagent in presence of dry ether which form complex or adduct which on acid hydrolysis form alcohol. Now take an example. Here we are taking ethanol means acetaldehyde RC double bond OH. It is aldehyde group. We are taking here CH3C double bond OH. IUPAC name is ethanol and common name is acetaldehyde, and it is react with methyl magnesium iodide, which is your Grignard reagent, and this ethanol undergo nucleophilic addition of Grignard reagent in presence of dry ether. So CH3 react with carbon atom or attach with the carbon atom, and magnesium and iodine is attached with the oxygen atom. So it forms complex as you have seen here. CH3 is attached here with the carbon atom and magnesium and iodine is attached with the oxygen atom. Now this complex is undergo acid hydrolysis. As you have seen on the arrow, HOH means water and H plus means acid. As I have already told you, two types of hydrolysis are there. One is alkaline hydrolysis and another is acid hydrolysis. So here we are using acid hydrolysis. From HOH means water, hydrogen react with oxygen atom, and OH means hydroxyl group is attached with the magnesium atom. So magnesium attached with iodine and OH group. It is your byproduct, and hydrogen attached with the oxygen atom, so it will become alcohol means CH3 CHOH CH3. As you have seen in your product, it is your alcohol, and the name of the alcohol is propane-to-ol, means it is your secondary alcohol, secondary propyl alcohol. With the same method, we are using a ketone. It is propanone, and the common name of this compound is acetone, As you have seen, it is R C double bond O R, means CH3 C double bond O CH3. This ketone undergo nucleophilic addition of Grignard reagent CH3 Mgi. You can use in place of CH3 any one of the alkyl group and in place of iodine any one of the halogen. Fine. So it is methyl magnesium iodide in presence of dry ether. It form adduct means complex, means propanone undergo nucleophilic addition with methyl magnesium iodide in presence of dry ether form complex which on acid hydrolysis form alcohol. Same process is there. OH is attached with the magnesium atom. Always remember, magnesium is attached with iodine as well as OH means hydroxyl group, and hydrogen is attached with the oxygen atom. So here you can form tertiary alcohol. As you have seen, the IUPAC name is 2-methyl propane 2-ol. So it is the last method for the preparation of alcohol. So student, from this chapter we have already discussed the introduction of alcohol, classification of alcohol, nomenclature of alcohol and preparation of alcohol. Let's further study the next topic from this chapter. It is phenol. Phenol means AROH. AR means aromatic ring. Phenol means the aromatic hydroxyl compound in which one or more hydroxyl group are directly attached to the aromatic nucleus. Students, I am repeating the definition of phenol. The aromatic hydroxyl compound in which one or more hydroxyl group are directly attached to the aromatic nucleus. Now, hydroxyl group, if hydroxyl group directly attached with the nucleus, it is phenol. But aromatic hydroxy groups are of two types. As you have seen, aromatic hydroxy group or compound are of two types. One is phenol and another is aromatic alcohol. What is the difference between these two groups? Phenol means OH group is directly attached to the carbon atom of the benzene ring, and in aromatic alcohol, OH group is present in the side chain of aromatic ring. See the example. In phenol, OH is directly attached with the carbon atom of benzene ring. Same here, OH is directly attached with the carbon atom of the benzene ring. But in aromatic alcohol, OH is not directly attached with the benzene ring, carbon atom of benzene ring. It is attached with the side chain of aromatic ring. So, phenol means OH group is directly attached with the carbon atom of benzene ring. Now, the next topic is classification of phenol. In this, the first type is monohydric phenol. As all of you know, mono means one. If one hydroxyl group is attached on the aromatic ring, it is known as monohydric phenol. See, in both the example, only one OH group is attached on the aromatic ring. So it is monohydric phenol. Now, the next one is dihydric phenol. Dihydric phenol means two OH group is attached on the aromatic ring. So it is known as dihydric phenol. Now next one is trihydric phenol. As you have seen, student, 3 hydroxyl group are attached on the carbon atom of aromatic ring. So it is known as trihydric phenol. So there are three types. One is monohydric phenol. One OH group or one hydroxy group is attached on the carbon atom of the aromatic ring or benzene ring. Dihydric phenol, two hydroxy group are attached. Trihydric phenol, three hydroxy group are present. Now the next topic is nomenclature of phenol. As all of you know, there are two methods for the nomenclature of phenol. One is common name and another is IUPAC name. Common name, student, always remember you have to learn all the common name of the compound. For example, if aromatic ring containing only one OH group, it is phenol. Aromatic ring containing OH group with the CH3. As you know, if hydroxyl group means your functional group is attached with the carbon atom, the next carbon is or next position of that carbon atom is known as ortho position. Another one is meta and another one is para. I am repeating here. Where the OH group is attached, the very next position of that carbon atom is known as ortho. Then next one is meta. Then next one is para. So OH group and CH3 means methyl group is present on the meta position. So it is known as CH3 is present on the ortho position. So it is known as orthocresol. Now see here, it is your OH group, it is ortho, it is meta, it is para. Ortho, meta and para. So para position containing NO2 means nitro group. So it is known as para nitrophenol. Now next one is two OH group are there. Second OH group is attached on the ortho position. It is known as catechol. In the next example, again two OH group are there, but second OH group is attached on the meta position, so it is known as resorcinol. In next, again two OH groups are there, but second OH group is attached on ortho, meta and para. Means see here the position, it is your ortho position, it is your meta position, it is para position. So second OH group is present on para position, so it is hydroquinone or quinol. Student, remember we are giving common name of phenol. Fine. If two OH groups are there, means it is dihydric alcohol, and if OH group is present on ortho position, it is catechol. On meta position it is resorcinol, and on para position it is hydroquinone or you can say quinol. Now see student, three OH groups are there. It is known as fluoroglycinol. Fluoroglycinol. Positions are OH, then 1, 2, 3, 4 and 5. See here 1, 2, 3. The arrangement in both the examples, arrangement of OH groups are different. So if the OH groups are attached with adjacent carbon atom, so it is known as pyrogalol, otherwise it is known as fluoroglycinol. So student, it is your topic common name of phenol. I am repeating here. The first example is phenol. Second one, CH3 group is present on ortho position, it is orthocresol. Next one, NO2 group is present at para position, it is para nitrophenol. Two hydroxyl group are there, where second hydroxyl group present at ortho position, it is known as catechol. Second hydroxyl group present at meta position, it is known as resorcinol. Second hydroxyl group present at para position, it is known as hydroquinone or quinone. Next two examples are trihydric alcohol. The position of the OH groups are different. If three OH groups are present, three adjacent carbon atom, it is known as pyrogalal, and otherwise it is known as fluoroglycinol. Now, taking a IUPAC name, so first example is obviously phenol, or you can name it is benzenol. Second one, OH group having number 1 position and CH3 group number 2 position. So now the name of the compound is 2-methyl-phenol. 2-methyl-phenol. OH on first position and CH3 on second position. 2-methyl and phenol. Next one, OH on first position, then second, third, fourth position containing NO2 group. See student, first, second, third and fourth position containing NO2 group, so it is 4-nitrophenol. Next one, 2 OH groups are there. Always remember, if 2 OH groups are there, so named as diol, and if 3 OH groups are there, so named as triol. So both the OH group are diol. Position you can number it 1 or 2, or you can number it 1 or 2. So it is benzene 1,2 diol. Same here, you can number it 1, 2, 3, or you can number it 1, 2, 3. 2 OH groups are there, so it is benzene 1,3 diol. Now next, again 2 OH groups are there, you can number it 1, 2, 3, 4, or 1, 2, 3, 4. So one OH group is at first position and another one is at fourth position. So your name is benzene 1,4 diol. Now 3 OH groups are there, means it is trihydric alcohol, so you have to name as triol. You can name as triol 1, 2, 3, 4, 5 and 6. See student, 1, 2, 3, 4, 5 and 6. So the name of the compound is 1, 3, 5 triol. 1, 3, 5 triol. Now next, 1, 2, 3. Numbering the OH group means numbering the nearby OH group. So it will become 1, 2, 3. It is benzene 1, 2, 3 triol. The next topic is preparation of phenol. In this, the first method is from chlorobenzene. The process is known as Dow's process, means from chlorobenzene we are going to prepare phenol by Dow's process. In this method, chlorobenzene is heated with excess of aqueous NaOH at high temperature and pressure, as temperature and pressure is mentioned here, which is followed by treatment, or which is hydrolyzed with dilute HCl to obtain phenol. Means two-step reaction reaction is there. In first step, chlorobenzene is heated with NaOH, and in second step, the compound which is formed, it is hydrolyzed with dilute HCl to obtain phenol. Just see the reaction. Chlorobenzene is there, react with NaOH at 623 Kelvin or 150 atmosphere. Sodium atom and oxygen atom is attached on the aromatic ring, and chlorine is react with the hydrogen. So your main product is sodium phenooxide, in which oxygen carry negative charge and sodium carry positive charge. So the product is sodium phenooxide. Next, in next step, this sodium phenooxide is hydrolyzed by dilute HCl, means hydrogen is attached with the oxygen atom on the ring and sodium is react with the chlorine atom. So your main product will be phenol, and the byproduct is NaCl, sodium chloride. Student, we are preparing phenol from chlorobenzene. The process name is Dow's process. In this method, first chlorobenzene react with NaOH at 623 Kelvin and 150 atmosphere. From NaOH, oxygen atom and sodium atom attached on the ring, and chlorine is react with HCl. The product formed is sodium phenooxide, which is hydrolyzed by dilute HCl. So hydrogen atom is react with oxygen atom and sodium is attached with chlorine. So your main product is phenol, and byproduct is sodium chloride. Now the next method is from benzene sulfonic acid. As you have seen, the formula of benzene sulfonic acid means aromatic ring contain SO3H group. If SO3H group is attached on the aromatic ring, it is your benzene sulfonic acid. So benzene sulfonic acid is fused with excess of sodium hydroxide, means NaOH. Benzene sulfonic acid is react with or fused with sodium hydroxide. As you have seen, benzene sulfonic acid is an acid and NaOH is the base. That's why the reaction is neutralization, where acid and base react and form salt and water. From NaOH, Na group sodium atom is attached with the SO3 group, and hydrogen is attached with the OH group. So your byproduct is H2O, and main product is sodium benzene sulfonate. See student, so benzene sulfonic acid is react with NaOH, neutralization reaction in which OH group is attached with the hydrogen atom and form water molecule, and sodium is attached with the oxygen atom and it will form sodium benzene sulfonate, which is nothing but a salt. So the formula of sodium benzene sulfonate is aromatic ring containing SO3 Na group. In second step, this SO3 Na group is again fused with excess of NaOH, means sodium hydroxide, and from which ONA oxygen atom or sodium atom is attached on the aromatic ring, and this SO3Na will be removed or will be react with the remaining part of NaOH group, and your byproduct is Na2SO3 plus H2. Means, see here student, here double quantity of NaOH is there. 2Na, from 2Na, 1 Na is attached on the ring. From 2 oxygen, 1 oxygen is attached on the ring. Now, how many sodiums are remaining here? 1, and from the ring 1. So 2 Na is there. How many sulfur is remaining here? S, only 1. So 1 sulfur is there. How many oxygens are remaining there? So from 2 oxygen 1 is attached here, 1 is remaining, and from the ring 3 oxygens are remaining. So it will become 3 oxygen and here 1 oxygen. How many hydrogens are remaining there? 2. So 2 hydrogens are there. Students, I am repeating here. SO3Na group is removed from the ring, and from NaOH, ONA group is attached on the ring. So just see here, from 2 sodium atom, 1 is attached here and 1 is here. From 2 oxygen atom, 1 is attached here and 1 is here. Okay. Total oxygen atoms in the reaction is 2 is here and 3. 3 oxygen atoms are there. Means 3 plus 2. Total 5 oxygen atoms are there. From 5 oxygen atom, 1 is here, 3 are there and 1 is here. Total 5 oxygen atoms are there. In the reaction, in the whole reaction, total sodium atoms are 3. 2 here, 1 here. See in the product, 1 sodium atoms is there and 2 sodium atoms are there. Means 3 sodium atoms. Now, see here, sulfur. How many sulfur are there? Only 1. So 1 sulfur is there. Now, hydrogen. 2 hydrogen atoms are there, means 2 hydrogen. So your reaction is balanced. Always remember, from NaOH, ONA is attached, and the remaining part of the reaction form your byproduct, Na2SO3 plus H2. Na2SO3 plus H2O. The name of the Na2SO3 is sodium sulfide. Now, sodium phenoxide. Take a double quantity of sodium phenoxide and react with dilute H2SO4 or sodium phenoxide on treatment with dilute sulfuric acid or H2SO4 give phenol. See here student, 2 hydrogen atoms are there which is attached with the oxygen atom. 2 double quantity of sodium phenoxide are there, means ring and oxygen atom both are in the double quantity. Sodium atom is also in a double quantity which is removed or react with SO4. It will become NO2SO4. NO2SO4. It is sodium sulfate. Student, double quantity of sodium phenoxide react with dilute H2SO4 means dilute sulfuric acid. From dilute sulfuric acid, 2 hydrogen atom attached on the ring and 2 sodium atom attached with SO4. So it will become sodium sulfate. I hope student you understand all these topics. Thank you.